In this video, I want to talk about limits at infinity. We have already talked about infinite limit, and this was when the limit did not exist. Limit did not exist, but the function was seem to approach positive infinity or negative infinity. That is, the function was tending to grow infinitely without bound or decrease infinitely without bound. For example, we talked about limit as x we approach 0 from the positive side of 1 over x is positive infinity, because if you look at the graph of 1 over x, as you're approaching 0 from the positive side, your graph is going to increase without bound. And obviously the limit does not exist because we don't have a finite value the function is tending to, but we denote what is going on, the function tending infinitely higher and higher with the infinity sign. And that was infinite limit, and this was when we denoted limit as positive infinity or negative infinity. Now we're going to talk about limits at infinity, and this is telling you what is happening to our function as x is approaching positive infinity or negative infinity, or sometimes even both. So let's look at question A. Limit as x is increasing without bound as x is approaching infinity of 8x cubed plus 2 over 4x cubed plus 3. I have a graph of what is going on right below, and this thing is from Desmos. Let me get the credit. Desmos.com. And the graph, the red graph that you see, is the graph of 8x cubed plus 2 over 4x cubed plus 3, which was our problem. And this blue line is y is equal to 2. And as you can see, as x is increasing without bound, the function is seemingly to approach but never touch this imaginary line, y is equal to 2. So we can say the limit as x is approaching infinity of this function is 2, and all this is telling you is that as x is increasing without bound, as x is 10, 100,000, 10,000, those thing that you're plugging x into is getting infinitely closer to 2. Now, how can we make sense of this? Why is this approaching 2? Well, one way to think about it is as x is approaching infinity, as x is getting bigger and bigger, this x cubed term is going to dominate the top and the bottom of this fraction. What I mean, let's consider x to be 1. Then at the top you have 8 plus 2. At the bottom you have 4 plus 3. Let's consider x to be 100. Then you have 8000000 plus 2 over 4000000 plus 3 at the bottom. And as you can see, this plus 2 and plus 3 is becoming rather insignificant compared to the values of 8x cubed and 4x cubed. That's increasing rather exponentially. It's not increasing exponentially, but like compared to the other parts of this expression, it is increasing much faster. So as x is approaching infinity, 8x cubed and 4x cubed is going to dominate. So this function, let me rewrite this: 8x cubed plus 2 over 4x cubed plus 3. As x is approaching infinity, it's almost as if the function is 8x cubed over 4x cubed. And this is becoming even more so as x is getting even closer to infinity. So we can safely decide x cubes cancel out. 8 over 4 is 2. So the limit is 2. And that's what's happening. And it's also approaching 2 as x is approaching negative infinity with the same logic. Now let's look at two more examples. B, limit as x is approaching infinity of 5x squared plus 2 over 4x cubed plus 3. In this case, what's going to dominate the top? The x squared term, 5x squared, is going to dominate. And what's going to dominate the bottom? X cubed term is going to dominate the bottom. Now, which one is going to increase much faster? Obviously, x cubed term is going to increase faster. So this thing is going to be like 1 over 2, 1 over 3, 1 over 10, 1 over 1,000, 1 over 10,000, because the bottom is increasing much faster than what's going on at the top. So this thing in the end is going to approach 0. So our limit is 0. Now let's look at C. 5x cubed plus 2 over 4x squared plus 3 as x is increasing without bound. Now up top, x cubed is dominating. At the bottom, x squared is dominating. But x cubed is going to be increasing faster than x squared. So in the end, the top is going to be much bigger than the bottom. So it's like 2 over 1, 3 over 1, 10 over 1, and so on. So this thing is going to increase without bound. So the answer, we can denote what's going on as by putting the infinity sign. So one way to summarize this, the limit for the rational function, let's call this numerator and call this denominator. How is there a fast way of determining this? And there is. If the degree of the numerator and degree of the denominator are the same, as in the case for A, the 8x cubed and 4x cubed is going to increase at the same rate. So the answer is going to be the ratio, or what you get when you divide the leading coefficient. Then you divide the leading coefficient or the coefficients of the x term with the greatest exponent. And if the degree of the numerator is less than degree of denominator, as was in the case for B, in this case, the bottom had a higher degree, so it was increasing faster. The function is going to tend to 0, so the answer is going to be 0. And if the degree of numerator is greater than degree of denominator, the function is either going to tend to positive infinity, or actually in this case, yes, positive infinity or negative infinity, depending on the sign of the leading coefficient.